because the network is a bit slow. So it says, I have started. Let everyone know they are being recorded. So you'll be sorted with people coming into the lobby. Right?
Who will admit them? Who will admit them? It will automatically come in.
No, because some of them are not using the My UNISA email address, so it might not allow them. Should I make you, Elisha, the presenter so that you can help us?
Admit them because I may not see them on time.
Yes. I'm making you the presenter.
I can suggest my dear friend Mahapa. You can make Mahapa.
Alicia, Alicia, no. Alicia was treatment.
Guys, you are eating Mr. First time, and Mr. Swami is very disciplined, unlike the young people, us. So who am I making the presenter?
Maybe I'll meet.
Okay, Mahapa, where are you? Oh, Mahapa, you are Mahapa. Thank you. Sharp. Bye. Bye, Mr. Slane. Thank you very much.
Okay, thank you very much, dear doc. Afternoon, dear student. Okay.
Afternoon once again.
Okay, no, thank you very much. And what I alluded to, the attendance is very worrying, but let's hope some of you or some of your colleagues or classmates, they watch this, especially offline. As I've said, I'm not sure whether this is downloadable. If it is downloadable, then it will save you a lot of data just to download it, and then from there share it among yourself. Then you'll be saving a lot of data. I'm not sure. Okay. Now, I don't know where to start because last week we did 4 units, Unit 9 and Unit 10. And today it will be Unit 11 and Unit 12. So I'm not sure whether to first finish this Unit 11 and Unit 12, which they are not that lengthy compared as to, and thereafter take questions on all these 4 units, or take questions from last week. So what is the suggestion? I'm really in 2 minds. Any for me is okay, but no. Let us finish this first. Let us look at Unit 11 and Unit 12, and if there is still time, then I can take any question from any of the 4 units. So if you have a question from the previous session, you can just simply share it just for a few minutes, so that we can finish this first. And then from there, we will take question. I will take question. And these 2 units, as I've said, they are not that long. So therefore, definitely today we will finish within 2 hours. Okay. Ready? I guess so. Now, as we have said, integration, I heard somebody saying differentiation is a little bit tricky compared to integration, and which I differ. Why? Because differentiation is straightforward. Let us be honest. Unless if you haven't done your homework, differentiation is straightforward. There are very, very few rules for differentiation as compared to integration. Why am I saying so? Is because integration, it involves a lot of techniques. And what is even worse about integration is what? There will be some functions, there will be some integrals that are not even integrable. You can't integrate them. So some, they are very simple, you can integrate them. Others, they are not that simple, That is why we have got many methods of integration, many techniques of integration. And as I've said, worse is that some you cannot even integrate them at all. You can't. Definitely you can't. So that is why I differ with those who are saying the integration is better compared to differentiation. But no, okay, it's fine. That is not today's topic. Now, today's topic, it will be under Learning Unit 11, Applications of Integration. And obviously, because it's application of integration, therefore the assumption is your integration is up to scratch because we are going to integrate somewhere. That is good. Now, under Learning Unit number 11, I'm not sure whether I can share the document here. I'm not sure whether I can share it here. That's right. That is this. Hopefully you can see it. Is it visible? Can you see it? What I've shared?
Yes.
Yes. Now, I'm not sure where is the pointer here. I can't see it here. Where is the pointer? Can you see the arrow here, my arrow here? I'm moving it here. Can you see it?
Yes, I can see.
Okay, that is Learning Unit number 3. That is integration right there on top. Applications of integration. And guys, these are the learning outcomes. At the end of this learning unit, you should be able to, number 1, calculate the mean value of a function. That is what we're going to do. Number 2, calculate the root mean square value of a function. And number 3, that is calculate the length of an arc of a curve. Now from there, this is the content. Okay, coming back here. With me, I always strive to do, say what? Understand the concept. Because once you understand the concept, then we can throw any question on you. Because when we say calculate the mean value, what we mean by the mean value? The mean value is like the average. You have got a function y equal to whatever x. By mean value, we are referring to what? Calculate the average of those values of y. What we are trying to say is this. Say with discrete numbers, say you have written 3 tests. In test number 1, you got 40. Hopefully you can see my board here. Test number 1, you got 40. Say test number 2, you got 60%. Now the question is, what will be the average? Obviously, the average, it will be test 1 plus test 2. That is the sum of these two. Divide them by their number. So it will be divided by how many tests? 2. Then the answer it will be 50 because it will be 40 plus 60 divided by their number, which is 2. The answer it will be 50. It's very simple. Why? Because these numbers, they are discrete, separate, so to say. But what about if you have got a function now, say something like this, y equal to x squared. Now the question is, find the average, that is, find the mean of this function where between x equal to, say x equal to 1, say x equal to 3. Then as you can see, draw this function is like this. Now they say, what will be the average of the values of y? The average of the values of y. Remember, this y, they depend on x. And this x, they're continuous. Therefore, these y's, they're continuous, unlike those s. So then it will be from 1 here up to 3 here. Now, there are values of y here. There are values of y here. Values of y here, which are continuous. But now the question is, can we find the average of this continuous y? While those continuous y, they depend on continuous x's. Then the question now is, what about their numbers? Because in the case of a test, we know how many tests we have written. Here, how many y's do we have here? We don't know. They are indefinitely many. Therefore, we don't know their numbers. So then, what are we going to use here? Divide by which number here? We can't even answer this. So now, but with the help of integration, this can be done. With the help of integration, this can be done. Hopefully we are together. This can be done. Done by what? Those who came before us. Those who came before us. They realized that no, to find the mean value, that is to find the average of a function. Remember, by a function, we have said we are referring to the values of y between certain limits. The formula, let us just go straight to the formula because your syllabus just expect you to know the formula and be able to apply it, not how to derive it. Although there's a document there on just how to show you how to derive it, but we are not going to ask you how to derive it. You just have to know it. The formula is this. And even in the exam, surely they will give you this formula in that formula sheet. It will be 1 over b minus a, the integral. That is the definite integral. The integral from what? From a up to b.
Hello, sir.
Yes.
I don't know if I'm the one who can't see your screen properly.
Is it everybody? Can you
Yes,
see?
sir. Can you please spotlight your, is it highlights or spotlight?
Highlight your spotlight. What do you mean? Highlight my spotlight?
Called spotlight. I'm not sure.
Can
Your
you make your
screen,
screen
sir.
Remember what
so we
you
can all see?
did last time.
Spotlight. Yeah, this thing of being born before technology. I'm clueless as to what do you mean by spotlight.
No, guys, you have to do it from your side. You can do it from your side. You want to enlarge the screen, right?
Yes, how do you do
Yes,
that?
yes, yes.
Yes. So you prioritize the video. Prioritize the video, then the screen for it will enlarge. I think on the more options, I don't know if you guys, what are you using to connect, because I'm using a laptop, and on top there's more options,
I'm
and
using
on
my
that
Okay,
now
it says here, it says here from my side, it says spotlight for everyone. And I'm trying to do, you will highlight your video for everyone in the meeting. Say yes, I clicked yes. But it still doesn't want to change. Can you still see me?
no, sir,
No.
we can't.
no,
No.
now we can't.
No, we can't say.
Yeah, it looks like here, my video here just disappeared. I don't know what is happening. The best thing is what? Let me just log out and come back again. Because I can't see my video here at, oh, look now. I've switched off my camera. Yeah.
Now we can see you, sir.
Is it, can you see the board now properly?
I can. I don't know about the others.
To those who are using
Can see.
phones, they can't see you properly. I can't remember what you did last week, Sunday, on your settings, because you were supposed to be seen on the entire screen.
Yeah, I also don't know what doctor did.
Can you guys do you have the tab that says view? On
Oh,
the
yes,
phone?
it's fine now for me.
It's fine now.
Yeah, it's fine.
It's fine.
Yeah,
it's
you,
fine.
yeah, I understand.
It's fine
Oh, we
now.
need term of views.
Yes,
Yeah,
sir.
it's fine now.
Okay.
Though you are in the dark.
Yeah, this is, hey, with me, I'm old man. This thing of technology, I'm used to face in class. This technology,
Yeah.
yeah, it's playing games with me. Okay, we are saying we are all fine, eh?
Yes, sir.
Okay,
Yes.
now, as you can see here, now the mean average is, but we just simply say the mean value. It will be given by this formula. That is 1 over this B is the upper limit, minus A is the lower limit. That is A from A to B of what? Of your function now. That is, it will be of Y. And then from there, you integrate this with respect to X. And then that will be the formula. And then from there, you are done. Unless if your problem is still what? Unless if your problem is still this part. Because Y, yes, in our case here, Y here is just a polynomial which is simple to integrate. But in some problems, the Y here is not necessarily a polynomial like this. Maybe it can be a trigonometric function, or it can be any function. As I've said, you may find that this function, because we are going to replace Y here by X squared, you find that the integral of this function here it's just difficult in some instances, and in some it can't be even be integrated. But we will look at those where this cannot be integrated. Now with this one here, now say we are saying here find the length, that is find the average of the y's, where y is equal to this. Let's say between 1 and 3, just like what we have said earlier on. Then the mean here will be 1 over. Then from there, we know 1 here is the lower limit, meaning it will be 1. And 3 here is the upper limit, meaning it will be B. Therefore, it will just be 1 over 3 minus 1. Now the integral of, now it will be from 1 up to 3. What is y? Y is x squared. Then you integrate it with respect to x, and everything now, it should be clear now. Because this, it will simply be 2. And then the integral of this, we know is the definite integral. Then it will be 1 over 2. Then you integrate this part, because it's just a power. Therefore, it will be the power rule. Then it will be x exponent 3 over 3. Then from 1 up to 3. And then everybody surely can integrate this, because it will just be 1 over 2 in brackets. As you have said, you open 2 brackets, because this is definite integral. open two brackets, bracket minus the second bracket. Then from there, you just use your calculator. Now, x is 3, then it will be 3 exponent 3, which is 27. Then it will be 27 over 3. In the second bracket, you still write this, but now with x replaced by 1. Then it will just be 1 over 3, and surely everybody should be able to finish it. Let us not even try to finish it, because it's definitely straightforward. Any question? Any question thus far? Any question? Then, if you look at it properly, let's say, let us forget about a half. Let us just talk about this. What is this? I'm seeing that some students here looks like they are faded, man. I'm not sure what is happening. Mulebaleng, can you still see us, Tabo? Are you still with us?
Yes, I can see.
Okay, what is happening? Because on my side says blue. I couldn't understand what does this blue means, the color blue means. Now, if you look at it, this is the area under this curve, y equal to x squared, from where x is equal to 1 up to where x is equal to 3. That is this, the interpretation of this. It gives you the area of the region below this. Obviously, it will be below this, but above the x-axis. Below x squared, that is, it will be this, as we have said. This is y equal to x squared. And this is from 1 up to 1 equal to 3. This thing is this. Now from there, now you divide it by what? You divide it by 1 over the difference of the upper limit and the lower limit. That is, you divide this, because it's divided by, you divide it by what? By 3 minus 1. That is how you should understand what? The mean value of a function. And that is all. We can just look at another example. Look at an example. But as we have said, once you understand the concept, according to us, then you should be able to answer any question. Unless, as you have said, the problem, it will be integrating, that is, finding the area under that curve. That's good. Say you have this. I saw something like this in your book. They say find the mean value. Find the mean value. I don't have to write everything. Find the mean value of y equal to, say, sine x. Now, where between, say, x equal to 0 and x equal to, say, pi over 2. How do you go about this? Find what? Find the mean value. That is the mean value. So what do we do now? It will just maybe what? Equal. That is 1 over. That is the formula. Although we don't have to write the formula before we can use it. But for practice sake, let us just write it. Now, it will not be what? It will be equal to 1 over. Now, this is the upper limit. Then the upper limit here is pi over 2. Therefore, it will be pi over 2 minus the lower limit. The lower limit is 0. That is 0. And please be careful here, because here they say x is this, meaning this x, which is an angle, is in radians, because they are not saying between 0 degrees and pi over 2 degrees. Therefore, the unit of your angle here, it must be in radians. Therefore, whatever you calculate here, make sure that your calculator is in radians. Otherwise, if your calculator is in degrees, then it's going to give you wrong answers. That's good. Now, from where to where? From 0 to pi over 2. And what is y? Y is sine x. Then you integrate this. And what is this? Pi over 2 minus 0. It is just pi over 2. And what is 1 divided by this fraction? We know 1 divided by this fraction, it will be the reciprocal of the fraction. That is this, it will now be what? 2 over pi. I'm just trying to save the space here. Now from there, you then integrate this part. And then this, it will be 2 over pi. And what is the integral of this? We know the integral of sine x is minus x, is minus cos x. Then it will be minus cos x. From where? From 0 up to pi over 2. Then we know we have to just open 2 brackets. And as you have said, make sure that your calculator is in the right unit, that is in radians. Otherwise, it's going to give you wrong answers. Any question thus far? Any question thus far? Nothing. Let us just take the very same thing and say, what about if you have got here, say 3x? Say 3x. And obviously, here it will be 3x. And what will be the integral now of sine 3x? What will be the answer here? The integral of sine 3x. We know this. We know this. You don't have to use those general approach, because this is the application of integration. Now, what is the integral of sine x? Let us start with this. What is the integral of sine x? We know is minus cos x. And what about the integral of sine of 2x? What will be the answer? Anybody? Colin? What will be the integral of sine 2x? The assumption is you can integrate. No, this is meaningless. It must be with respect. Otherwise, this is meaningless. What is the integral of sine 2x with respect to x? Anybody?
Minus 2 cos x.
0.
Minus 2
Sorry.
cos.
Yes, is 0. You see, that is what we are saying. What? Because yes, I agree with you. Some of you will understand the concept, only to find that the implementation, finding the integral, then that is where you get wrong, and then you are totally out now. That answer is wrong. We'll tell you why. Anybody?
Is 1 over 2 cos 2x.
Is 0 again, another 0. 2 students, 2 zeros.
Come again, sir. Mine.
What is the integral of sine 2x? What is the integral of sine 2x?
We're gonna use what do you call that one? Hey.
Yes, that one.
Yeah, which says 2 sine 2x cos 2x.
0, 0, 0. 3 different students, 3 zeros. Yeah, that is why I said what? Make sure that your integration is correct, because now maybe you understand the concept very well, but now integrating then becomes a problem. So you will only get maybe 1 mark for this, for constructing the formula, and this one is wrong, because this one must be correct. If this is wrong, then everything becomes just null and void. You will just get 1 mark. Now, going back here, let's come back here. Be careful. We are integrating sine something. So which formula are we going to use? We don't have to go back there. the formula that we are going to use is this. This is the formula that we are going to use. Is this one. Let us take this out. That's for space. Just to create space here. What will be the answer? And what is very important, before going any far, what is very important is what? Here, no. It must be f of x here. Very, very important. It must be f of x here. What is very, very, very key is what? A sine something. It's not sine squared. It's not sine cubed. A sine of a function. Function. This function here. Indeed, it can be any function. It can be a polynomial, like 2x, like 3x, or whatever. It can be another trigonometric function, like cos x. It can be an exponential function, like e exponent x. It can be a hyperbolic function. It's f of x, any function. And what is very, very, very important before we even go far, here, this, it must be the derivative of this. Maybe except for a constant factor. Hopefully it makes sense. Say you are integrating what? Sine 3x. Sine 3x. What is our f now here? This f of x. This f of x is how much now? Is 3x. You see, it's 3x. Therefore, according to this, we must have this guy, which is the derivative of f. That is, we must have the derivative of 3x here. And what is the derivative of 3x? It's 3. The derivative of 3x with respect to x is 3. Do we have 3 here? No, we don't have 3. What we have here, we have got 1, not 3. Now, compare what you have here and what we should have according to this formula. Otherwise, you will have the general approach, which is going to take long, you see. So hopefully we are still together. Let us just clean this, all of this. Now, what we do here is what? We need 3, not 1. Then what do you do? You then write 1 using what we need, which is 3. So how can we write 1 in terms of 3? Because we don't need 1, we need 3. How can we write 1 using 3?
3 over 3.
3 over 3. We haven't done anything here. We've just written what we had here using what we need. Then from there you say, okay, 3 over 3 is the same as saying 1 over 3 multiplied by 3. This 3 over 3 is this. Then you say sine of 3x dx. You don't have to rewrite this like this. We're just going to say, giving you an example so that we can now go and use those shortcuts. Now from there, we are not going to say, we have got 1 over 3 and 3. 1 over 3 and 3. Which one of these two? Which one of 1 over 3 and 3 according to this? We need it here inside. Do we need 1 over 3 or do we need 3? Is 1 over 3 the derivative of 3x or is 3 the derivative of 3x? Is 3. Therefore, we don't need 1 over 3 inside here. Then we can just take it out. Why? Because we can take 1 over 3. Why? Because 1 over 3 does not depend on x. We know it. If something doesn't depend on x, we can take it outside or you can take it inside, depending on where do you want, what do you want, according to the context. Here, we don't need 1 over 3. Then we can just say 1 over 3 is out now. Then we say the integral of what now? 3 sine of 3x with respect to x. Now, if you compare these two now, these, what is happening with my mark? This, I'm not sure whether this is visible. This part is now comparable. This hopefully makes sense. It's now comparable. Your f of x is 3x. Sine is sine. And what is very important is what? The derivative of f. The derivative of f, because this one must be the derivative of f. And indeed, 3 is the derivative of 3x with respect to x. Therefore, this is comparable to this one. And according to this rule, what is the answer? Is minus cos the function plus c. But because here we're dealing with the definite integral, we don't even have to include the c. Hopefully this makes sense. The answer is this one. So therefore, now coming back here, then the 1 over 3 is outside. 1 over 3 is outside. Now, we are now going to replace this. Using the right side of the formula that we are using. Then this becomes 1 over 3 is outside. Then you replace this part. Using the right side of this. What is the right side of this? The right side of this says minus cos the function. So it will be minus what? Minus cos this. It will be this. Anything else, it will be 0. Hopefully this makes sense. The integral of, remember here, there is 1 here, Don't even write it. The integral of sine 3x with respect to x. The integral of sine 3x with respect to x. The only correct answer is this one. Anything else, it will be 0. Integral of this, only correct answer is this one. Where you can just write what? Minus 1 over 3 cos of 3x. Does it make sense? If you're not sure, what do you do? Take it, differentiate it, take this, differentiate it, simplify it, and then it will give you the integrand back. The derivative of this, it will give you this back. And nothing else, it will give you this back, the integral of this one. Does it make sense now? Mandisa?
Yes, sir.
Yes. What is the integral of, say, sine 4x with respect to x? Because as you can see here, that let us just write the minus here. The answer is going to be minus. Minus what? Now, this is 4x. Therefore, we need the derivative of 4x, which is 4 here. And because then you write it. Then from there, what? You cancel it by writing its reciprocal outside. That is what we did here. 3 is the derivative of 3x. You write 3, and then you cancel it by writing its reciprocal outside. Then from there, the answer is going to be this 1/4, which is outside. Then you write cos 4x. Then it will depend on whether it's just indefinite integral or definite integral, whether you need plus c here or you don't need it. But under our context, we were talking about the definite integral. Therefore, we don't even need it a c. Hopefully that makes sense. Because many of students, they understand the concepts, but then the problem is still integration. They get integration wrong, and then from there, everything now becomes 0. Hopefully that makes sense. Why I'm trying to emphasize this is what is because even with the next topic, you will still have to integrate. Even with the next topic, you will still have to integrate. So if you can't integrate, then it becomes a problem. You see. Hopefully this makes sense. The same story. The integral of, say, cos of 5x with respect to x. What we will answer? Hopefully nobody will get it wrong here. From there we can now proceed. What will be the integral here?
1/5
Anybody?
sine.
Come again?
1/5.
That's correct. It will be 1/5 sine 5x.
5x.
It will be
Yes.
1/5, then sine what? Sine 5x. Then from there, you can just simply add plus c if it is indefinite. Otherwise, once you understand this, then everything becomes very simple because do it to be under learning 11 and learning unit 11 and learning unit 12 and so on and so forth. You will have to integrate some functions, and many of these functions, they will be like what? Trigonometric functions, yeah, sine x and sine t, cos t, and whatever. So once you understand the integration, then everything, we can even call it this session off, because everything will just be straightforward. We don't even need another example under the mean value functions, because what your function like this, the m here equal to 1/b minus a, the integral of this one from a to b. These the function, as we have said here, it can be any function. Then to integrate this, you will be expected to use any integral technique. It can either be straight, or it can be what? It can be those the what do you call them? The integration by parts and whatever. Good. Now, the next topic under learning unit 11. Hopefully you are still there. The next topic under learning unit 11 is what is called root mean square. And what we mean by root mean square, what we mean by that is the following. Sometimes, especially when you have values of y, take what? The negatives and the positives. If they take the negatives and the positives, then when you combine this, they will obviously cancel each other somewhere, somehow. And then finding that now the mean, it doesn't give a true reflection of what is happening. Because you are saying with the mean value, number one, your function must be continuous. Number two, your function must be above the x-axis. But once your function, yes, is continuous, but it's taking the negatives and the positive values, then sometimes the mean value, it doesn't give you a true reflection. Not to say it's wrong, but then it doesn't give you a full picture of what is happening. So to avoid your y values taking both the positive and the negatives, what do? You square it. And once you square it, then we know it will only take the positive numbers. And then from there, but the main aim is not to find the average of the squares. Then how do you reverse? Because you have squared the y value so that you avoid mixing the positive and the negatives. So once you square, then it becomes what? Only the positives. But you find that maybe your aim is not to find what the mean of the squares. You want to find the mean of the function. You are not interested in the mean of the square of the function, but the mean of the function. Then how do you reverse that square part? Then you find the square root. So that is why it's called the root mean square. That is the root mean square. And what for that? The formula for that, let me just create a space here. Let me create a space here. The root mean square, what is the answer? The answer, it will be the square root. Remember, with the mean, there is no square root. But now here, the root mean square, that is the square root, we are reversing the square now. Then it will be 1 over b minus a, where b is the upper limit and a is the lower limit. The integral from a to b, the same story. And instead of y, you now have y squared. Why y squared? We are preventing mixing the positives and the negatives. So then you say with respect to x. Then from there, it will now depend on what is the lower limit, what is the upper limit, and what is your function y. Then you integrate this. Then that is all. Now, if you lose this formula as it is, can you imagine? Maybe you're going to write 25 steps here. Step number 1, the formula. Step number 1, the substitution. Step number 2, then you'll be writing square root here, the next thing the square root here, the next thing the square root here, so on and so forth. How many times are you going to repeat this, writing the square root, the square root, the square root, until the final answer? So some people, they will say, instead of writing the square root all the way until the end, they will do what? They will remove it right from here. It will depend on the book. They will remove it right from here. Instead of saying RMS is equal to the square root of this, it will just say RMS, then they square this, and the square of the square root, obviously, they will cancel each other. Then you square the left side, then it becomes this. Now the right side is now nice now, without the square root. We are now going to write this without the square root. We are now going to write this without the square root on the right side. You will write the next step here where you just substitute, not forgetting that if you have got your y, equal to sine x, then this, it will now be, let's say in this, from x equal to 0 up to x equal to whatever, say pi over 2. That is a question. Find the root mean square of this function in this interval. Then what you do? This is the formula, which is equivalent to RMS equal to the square root. Now here, it will now be 1 over, the upper limit is pi over 2. The lower limit is 0. The lower limit is 0. From 0 to pi over 2, now this one then becomes sine squared. It then becomes sine squared with respect to x dx. Then it will be this. And then from there, we know it. This is this. 1 divided by this is just the reciprocal here. Now you have to integrate this. sine squared x. And what is the integral of sine squared x? We know that what? How many trigonometric functions do we have? There are 6. We know them. 2 of them, they are standard. They are standard. The next 2, they are not standard, but they can be written using the first 2, which are standard. And the last 2, which is sine squared x and cos squared x, they are not standard and they cannot be written using the first 2, which are standard. So how do we integrate sine squared x, which is very similar to integrating cos squared x? We are not going to go into that. How do we integrate sine squared x? That is where you are now going to use cos 2x. We know it. That is cos squared x is half in brackets 1 plus cos of 2x. We know it. That is what? The x here, this is 1, the x here. What about this side? You just multiply it by 2. Cos squared x is half in brackets 1 plus, instead of x, you times it by 2. We know this. We don't have to go there. Like, what is cos squared 3x? What is cos squared 3x? It will be half in brackets 1 plus cos what? Then you take this and you square it. So it will be 6x. So now instead of integrating cos squared x, you are not going to integrate this. Instead of integrating this, you are now going to integrate this. The same story. What about the integral of, what about sine squared x? Sine squared x, we know it will be half in brackets 1. Instead of plus, it will now be minus. Minus what? Now, cos of this 1x. Now you take 1x, you multiply it by 2. Then it becomes 2x. Now from there, you can now integrate this, which should be very simple now. From what we've just done now, it will be very simple. Everybody can do it. It will be very simple. It will now be what? 2 over pi. You can just simply multiply it by this because this is a constant. It doesn't depend on x. You can just simply take the half outside. Then it will be 2 over pi multiplied by half, which will just simply be 1 over pi. Then multiplied by what now? The integral, which is x, because it's the integral of 1 with respect to x. And what is the integral of this one? It will be minus what? Half sine 2x. Where from? From 0 up to what? Up to pi over 2. Then you use your calculator to do this. Where you know you just have to open 2 brackets. In the first brackets, you write the very same thing, but with x replaced by pi over 2. Then you say minus. In the second brackets, you write the very same thing, but with x replaced by 0. And we don't even have to talk about the second brackets, because in the second brackets, if x is 0 and x here is 0, this it will be 0, this it will be 0. Therefore, we can't even talk about what? The value in the second brackets, because everything in the second brackets, it will be 0. Therefore, the answer here will be 1 over pi multiplied by the first brackets for this. Now from there, that will be the, it's not going to be the RMS, don't forget. It's not going to be the RMS. It's going to be the square of the RMS. Not the RMS, but the square. Now from there, once you get this answer, then how do you find the RMS? Then you find its square root. The square is just to avoid writing the square root here, the square root here, the square root here, the square root here. But if you think you're going to forget, if you're going to forget that the answer here is not the RMS, but is the square of the RMS, you better just keep on writing the square root here, the square root here, the square root here, until the final answer. Otherwise, everything straightforward. Any question thus far? Any question thus far? Any question? Any question?
Can I ask, sir?
Yes, yes.
Where you integrated cos 2x, where is the half coming from? That half
Where?
sine x.
I thought we have explained it. But don't worry. Let us explain it again. Where were you? I thought we have explained it. We took about 5 minutes, 10 minutes trying to,
That's right. Apology.
explain this. We have said, what is the integral of, say, sine x? We have said which formula we're going to use. We are going to use the one for this. We have said we are going to use this. This is the formula. Can I erase this? Because your question is only this one. So therefore, let us erase this so that you can understand it better. Now, what is the answer? Make sure that your integrand is exactly of this form. And I tried to emphasize this. That is to say, your f here can be any function. And once you have your f here, what is very key is what? You must have its derivative here, except for a constant factor. So once your integrand matches this formula, and you know you are going to use this formula, then what is going to be the answer? Minus cos the function. Hopefully that makes sense. What about here is our f is x. Then according to this, you must have the derivative of x here. And what is the derivative of x? It's 1. Do we have 1 here? Yes, we have got 1. Therefore, according to this formula, what is the answer? The answer is minus cos x. Are we together? Yes. Now the question now is, what about the integral of sine of 2x with respect to x? Which formula are we going to use? This is sine. Therefore, we are going to use it. Sine. Our f is 2x. The question is, do you have this here? That is, do we have the derivative of 2x here? Do we have the derivative of 2x here? Because here now, there's nothing. Then it means there is 1. There's nothing. Then it means there is 1. Is 1 the derivative of 2x? No. Therefore, you can't use this formula. Then what do? We have said, because we can write 1 using 2, because the actual derivative of this is 2. Because we can write 1 using 2, then let's do it. You write 1 using 2. Then it will be this. This you still have your 1. You can't say no, this is not, because we have just written 1 using what we need, which is 2. This is still 1. And then we have said 2 over 2, it can be seen as what? Half multiplied by 2. Now the question now is, remember when we were looking for this, and between half and 2, which one is the derivative of 2x? Between half and 2, between half and 2, which one is the x? Which is what we need here. Said it's half. Then what do you do with half? It's a constant. Then you can take it outside. You can take it outside. Then this now, this dx is dx. Your f of x is 2x. Your sine is sine. And very important now, the derivative of f of x. This is the derivative of this. This is the exact derivative of this. Therefore, we can use it now to answer this. Forget about the. Therefore, the answer is going to be half. Now you replace this part according to this. What is the answer for this one? Because the answer for this one, it will be minus cos the function. So therefore, this will be half multiplied by what? What is the answer for this? Minus cos of 2x. That is where this one comes from. Although we used sine here, but this is cos, but the two are similar. I'm not sure whether you understand, because I even asked you this before even going further. We have said, what is the integral of cos? Let's say the integral of cos 3x. What is the integral of cos 3x? It will be how much? You need 3 here.
Okay.
Then the answer is going to be 1 over 3 sine 3x. It's going to be this. That is the answer. But now here this minus. Don't forget. Because the derivative of this, it will be a half. The derivative of it will be a half. Then you differentiate this. It's going to give you 2 cos 2x. It will be a half multiplied by 2 cos 2x. That half and 2, they will cancel each other. Then it will give you this at the end. Does it make sense?
Yes, it does.
Yes, it does. So that is why I was saying, go back to integration. Go back to integration. Go back to integration. Because yes, I agree with you. Sometimes, yes, not even sometimes. Most of the time, you find that somebody understands the concept. But now the problem is what? The prior knowledge is the one that is leading them down. So, but it's not too late. You can go back and integrate. And now the next topic here, I'm looking at the time here. The next topic here is the length of an arc of a function. That is the length of a piece of a function. How do you find it? Using integral method. Start with what you know. Start with what you know. Say you have got what? Y equal to whatever, y equal to 6. This is the y equal to 6. Y equal to 6. They say, what will be the length of this function? Because it says the length of a curve, the length of a function. This is a function, this is a curve, it's a graph. Say between what? Between x, say between x equal to 1 and x equal to 4. What will be the length of, because this is a graph of y equal to 6. What will be the length of this between x equal to 1 and x equal to 4? Anybody, Mahapa? What will be the answer? What will be the length of this? Because here, we're not just going to give you 6. We can find what? We can say, what is the length of this? I'm just starting with something very simple. We can say, what is the length of sine of x? Which will now be sine of x. You draw sine of x. Now from there, you find the length of that arc, of that piece of that graph, from where x equal to 1 up to where equal to 4. But now start with something that you are familiar with, and from there build on it. What will be the length here? Let's say let's call it L. What will be the length? It will simply be what? What is y when x is 1? It will be how much here? What? It will be 1 and 6. Up to where? Say x is 4. What about the coordinates here? 4 and 6. What is the length of this? Start with something that you know. What will be the length of this? It will simply be what? Because it's a horizontal distance now, it's horizontal. It will be x on the extreme right minus x on the left. It will be, what is x here is 4, minus what is x here is 1. Therefore, this, it will be how much? Then this, it will be 3. It will be 3. It's the same story, the same story, the same story. What if now? Don't forget, you can just stop us at any time. Stop us at any time. Say you have quantities. Y equal to x. Then I say, what will be the length of a piece of this? That is an arc. From where x is, say 1, up to where x is, say 7. Now you draw this graph. Y equal to x. That is the graph. Y equal to x. That is this. Y equal to x. X is always equal to y at any point. They say from where? From x equal to, say, 1 up to x equal to, say, 7. Meaning from here, that is from here up to 7 here, that is somewhere here. That is what? What will be the length of this from here to here? What will be the length from here to here? Using integration. But we know this. Using somewhere grade 11 or grade 12, grade 10, we can find the length of this. How? Because this is like what? If you draw something like this, we know what here, this is what? 1 and 1, the coordinates here. And what about the coordinates here? It will be 7 and 7. And what about the coordinates here? X is 7, y is 1. Then this is a right-angled triangle. And using that hypotenuse, we can find this. Because we know the square of this, it will be equal to the sum of the squares of this one and this one. So there's no problem, we can find it. But now the question is, what if now you have got something like this, which is not standard, which is not a straight line like this one? Because here you can just simply draw a rectangle, and what we use that distance formula, we will get an answer. Using the distance formula, we will get the answer. But now what about if you are curve? Because we're saying a curve, it can be any. How do you find the length now? Say from here, don't forget, it will not be something like this. Say from here up to here. Say from x0 up to pi over 2. That is, what is to be the length of this? The length of this. Hopefully that makes sense. Or it depends on this function, because it will be the function. And once you understand the concept, once you understand exactly what are we looking at here, then the formula becomes very simple. Although we are not going to look into that formula, we will just simply apply it. So what is the formula for finding the length of an arc of a function given certain intervals. That is from this, where x is how much, up to this, where x is how much. Remember, we can even spin it and say from where y is this up to where y is this. And in that case, we are going to integrate with respect to y. And in that case, our function is not going to be given as y equal to this. It's going to be given as x equal to this. Remember this formula, just use whatever. So the formula is this, and it's straightforward. Where is that formula? I don't have it here. I haven't written it here, but we can just simply talk about it. There is no problem. There is no problem.
Sir, can I give it?
Come again?
Can I give you the formula?
Yes, I was looking for it here. Is how much? Is L equal to how much? The integral from
A to B.
It will be the square root of 1 plus dy over dx all squared with respect to x from A up to what?
B. Yes, sir.
That's right. That is the formula. I haven't written it here, but can still remember that formula. And then from there you are done. From there you are done. Definitely, we don't even need an example because let's say it is. Let's say it is. Let's say it is. This is your function. Now from there you are done. So simply because it will not be what? It will be, we will need to say x between what? 0 and what? And pi over 2. Let's say then it will not be what? I'm not sure because this one is going to be tricky because it will be the square root of it's going to be a little bit integrating this because it will not be 1 plus and then it will be this is not going to be it's not going to be a what? Let's say let us say what? Let's say cos. Because otherwise, if you write it like this, it will not be what is dy dx if y is this. And what is dy dx? Dy dx, it will be dy dx, it will be how much here? It will be cos squared x. No, it will be this. Dy dx, it will be this. Then this becomes from where? From 0 up to pi over 2, the square root of 1 plus, then you say cos squared x dx, then it becomes it is because this one is not what? It's not an identity. You see, this one is not an identity. Then it becomes a problem. The problem is the identity is 1 minus. So now given something like this, then it becomes a problem. That is why I was saying what? Integration is not just a straightforward process. You cannot just think of something from the top of your mind. You can find that now you see we're stuck here, integrating this. You see, hopefully it makes sense. But if maybe this, it was like what here? Say 3x, you see. Say maybe whatever, say, so that this, it will be, say something like this. That is what I'm saying. Integration is not just a straightforward process. Say y equal to whatever. I'm thinking something that will come and work properly here. Oh, because the square root must go. Or if it doesn't go, it must be something like, say, 1 plus what? 3x over 2, all exponent half, dx from whatever, from 0 to 4. Yes, if this becomes this. If this after the substitution becomes this. If this after the substitution becomes this, then we can integrate it. You see, then this one we can integrate it. Because it will not be the general power rule. Unlike the earlier example, the general power rule. You are not going to say we are going to use this, the general power rule. we are going to use this formula. Like the one that we have spoken about to say, what is n? N here is half. N is half. And what is f? The function inside the brackets. This is the function inside the brackets. Now the big question is, do we have the derivative of this? Do you have this guy that is the derivative of f? Here, the question is, no, we don't. Then you ask yourself, what is the actual derivative of this? The actual derivative of this is 3 over 2. Then how do you cancel? How do you counteract this? Because it was not there. Then you write 2 over 3 outside. Then it will be this. Then it becomes 2 over 3, this one that is outside. And what is this? According to this formula, this, according to this, it will simply be f exponent what? N plus 1 divided by n plus 1. Why? Because n is not minus 1. If n is not minus 1, n here is not minus 1, then we can use it. Otherwise, if n here is minus 1, that is, if n here is minus 1, then it will be lean. But not forgetting this. Then you then find the answer for this. With the 2 over 3 outside. What is the answer? Then the answer is going to be 1 plus 3x over 2 exponent what? Then it will be half plus 1. Obviously, half plus 1 is 1.5, which is 3 over 2. Then you cancel this by 2 over 3. Then it will be this. Then you integrate this. No, we have already integrated this. Then you evaluate it from where? From 0. From, it will now be what? From 0 up to 4, which is a definite integral. And then that will give you what? The length of that piece of this graph. Of this graph. Don't forget, of this graph. Of this graph. From where x equal to 0 up to where x is equal to 4. I think that is, it will be straightforward. It will be straightforward. Any question thus far? Any question thus far? Are you still at Mandisa?
Yes,
No,
I'm here.
Mandisa is gone. Mandisa is gone.
I'm here.
Any question thus far? Any question thus far? I know students they will just seem like, oh, but you sometimes you get confused with it, but who is cheating who? Because they will just simply log in and what? And go somewhere. Go and buy Spalpro and somewhere. They are not there. But there's no problem. There's no problem. Don't forget, as we have said, please, you can just stop us at any time. Then from there, we will try to go through this as many times as possible. As many times as possible. Now, that is all about number 11. Learning unit number 11. Now, number 12. If we may, number 12. Number 12, it has got what? 3 topics. 3 topics. And as we have said, with integration, unlike differentiation, integration is not a straightforward process. Sometimes, yes, your function, it will be very simple to integrate because maybe standard. Sometimes It's not that straightforward. It will need techniques. We know all those techniques by parts. Some they say trigonometric substitution. Some they will say like sine squared. You use this using another what. It's not a straightforward process. That is integration. And as we have said, worst part is what? Some of those, they are just not integrable. Like the square root of 1 plus cos squared x. Then this one, forget. It's going to be a little bit tricky, where you have to integrate this. It's not just simple. But now the question now is, what is the whole idea in integration? The whole idea in integration is to find what? The area under that curve. That is the whole idea of integration. And then after it was expanded to what about the region that is enclosed between two different graphs. That is where now you take the top function and subtract the bottom function and you integrate the difference, so on and so forth. But as we have said, some functions, some integral cannot be integrated. But the question is, can we still find the ultimate results? Because the ultimate result is finding the area. Now, fortunately, those who came before us, they derived formulas to say, even if we cannot integrate this integrand, but we can still approximate the area. Hopefully that makes sense. Even if we cannot integrate this, but we can use this rule, we can use this formula to approximate the area beneath this function from where x is how much up to where x is how much, or from where y is how much up to where y is how much. And one of such formula is what is called the trapezoidal rule. We are now under learning unit 12. That is the formula. Trapezoidal. Another such formula is what is called Simpson. Another such formula is what is called MAT ordinate. Now it will depend on the question. Which rule to use to approximate the area? They can say use trapezoidal. They can use Simpson. They can say use the MAT ordinate rule to approximate the area under this curve from where x is how much up to where x is how much. Now, let's get straight into trapezoidal. Now, this rule says this. This rule says this. The approximate area under this curve, within this, it will be given by this. Say approximate area. It will be given by this formula. That is 1/2. We will come and try to explain this. Explain this. Now, B here is your upper limit. And A is your, no, look now, I've written 2 here. A is your lower limit. B upper limit. A lower limit. And N here, we are going to say this. Say something like this. From here up to here. Now, this is A, this is B, and this is your Y equal to whatever. What we are going to do to approximate it is we are going to say, okay, let us then subdivide this region because we are looking for the area of this region. Looking for the area of this region. Let us subdivide this region into n equal parts. N, it will be the number of equal parts. They can simply say, let us divide this into let's whatever of equal length. That is, from here to here, it must be the same as from here to here. It must be the same as from here to here. It must be the same as from here to here. It must be the same as from here to here. Hopefully it makes sense. They will then say A here, let us call it X0. X0 is your A. And then this one here, let us call it X1. This one here, X2, until B here is Xn. Hopefully that makes sense. But don't forget, the length X1 minus X0 in length is the same as X2 minus X1. If X1 minus X0 is 4, then X2 minus X1 must also be 4. X3 minus X4 must be 4. X5 minus X4 must also be 4. Hopefully that makes sense. Now from there, you then multiply this. Let me start it here so that this formula can suit in here. They say A here, that is an approximation. It's not necessarily the exact area because we're just approximating it. So we're saying it will be 1 over 2 here, B minus A over N in brackets F of X0 plus F of X1 plus F of X2 plus until F of the last one, where X0 is A and Xn is B. Hopefully this makes sense. And then they say this formula, it will give you the approximation from A to B of that Y with respect to X. Let us pause here. Are we together? Surely we are together. Why? Because we cannot integrate this Y. We can integrate this Y. But now, how can we, what would be the approximation of this area? Because this is an area. It's a definite integral, therefore it's an area. How can we interpret? How can we approximate this? Even if we can integrate Y, then they say this, it will be the answer. Hopefully that makes sense. Hopefully that makes sense. If not, then you tell us. Then we will go through it again. And this is what is called the trapezoidal. Good. Now, what we are going to be given is what? Is Y, your function, whatever. Let me just use this as an example. Which one here? Do we have it here? I can't see it. So, okay. Say this is from the book. It will be this. Your Y is X cube, although we can integrate X cube. They're just simply using it as an example so that you can compare the two answers. Now, they say use the trapezoidal rule with n equal to 6, meaning, don't forget, this is your graph. This is your graph. Y equal to X cube. Now they say from where to where, according to this, from X equal to 0 from x equal to 0 up to x is equal to 2, meaning in this interval, here x is equal to 0 up to x is equal to 2 here. They say approximate this, the area of this region, using trapezoidal rule. And this is the formula. Although we can still integrate this, but I say use this, then compare the actual area, because we can integrate this, and what? The approximation using this rule. Hopefully that makes sense. And then where do you start now? You have got n. N is 6. N is 6. And what is b? B is the upper limit, meaning b is 2. B is 2. This is equal to b. And what about a? A is the lower limit, meaning this is a. This is equal to 0. Then I say, now you must now cut this into how many parts? Into 6 parts, meaning you must now take this and cut it into 6 equal parts. 6 equal parts, more or less somewhere there. Hopefully that makes sense. And then what next now? What next now? What next now? It will now be, according to the formula, it will be 1 over 2 by what now? B is 2, then it will be 2 minus 0 divided by 6, which is 2 over 6, which is 1 over 3. This is 1 over 3. Then it will now be 1 over 3. And what is this 1 over 3? Then this 1 over 3, it will be the length of each of those 4. No, the length of each of those 6. Meaning from here to here is 1 over 3. 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 1 over 3. I'm not sure whether there are 6. 1, 2, 3, 4, 5, 6. It doesn't matter. That I just need to take this out. Meaning from here to here is 1 over 3. From here to here, 1 over 3. From here to here, 1 over 3. Meaning once we get x here, then to find the next x, you will say x here plus 1 over 3. Then you get x2. To find x3, it will now be x2 plus the length of this, meaning x2 plus 1 over 3. You just keep on adding 1 over 3, 1 over 3, 1 over 3. The first x, x0, it must be 1 over 3. Then you x1, I don't know. X2, I don't know. But the last one, it must be 2. The last one, it must be 2. Because the last one is, this is A. And this is B. Let us pause here. Are we together? Is there anybody who is being left behind? No.
So we are still here.
You are still alive. Good. Then what next now? Then it will now be, what is f of x2? No. What is f of x0? X0 is, what is x0? Is 0, ne? This is 1 over 3. X0 is 0, because x0 is this one. It's A. X0 is A. Then we're studying at A. Therefore, x0, it will be 0. Then you must now find f of x0. Meaning we must now find f of 0, because x0 is 0. And what is f of x0? If f of x is this, don't forget, this is f of x. This is f of x. So what will be f of 0?
0.
Then plus Plus what now? Plus, no, I think we made a mistake here, ne? The formula, the trapezoidal. We made a mistake here, ne? This, it
Yes.
must be what here? 2. There must be what here? 2. And then here, there is nothing. The first one is just f of x0. Then the last one, it is just f of xn. And this one in between, it will be 2f of x1 plus 2f of x2 plus 2f of what? It will depend on how many. It will depend on n. Hopefully that makes sense. So then this will be 2f of x1. X1 is 1 over 3. Because we have said we are going to move by 1 over 3. You start here, then you keep on adding 1 over 3, 1 over 3, 1 over 3. Therefore, this, it will now be what here? It will now be f of 1 over 3. Now from there, you're going to multiply it by this. So then it will be 2 multiplied by what? 1 over 3, all what? All cube. Because that is f of this. This is f of x. Therefore, f of this is this. So what will be x2? X2, it will now be x1 plus, which will be 1 over 3 plus 1 over 3, which is 2 over 3. Therefore, this, it will be f of this, which will be 2 over 3 all cube. Then it will now be 2 what? 2 over 3 all cube. It will be this. Then here, let us just create space. How many? It will now be plus until the last one is 2. Then after this, it will be, that is x3. What is x3? It will be 2 over 3 plus 1 over 3, which is 1. Therefore, it will now be f of 1. Then this will be 2 multiplied by 1 plus the last one, it must be 2. It will now be x4. What is x4? It will now be 1 plus 1 over 3, which is just 1 and 1 over 3, which is 4 over 3. It will be this, because it's 1 plus, that's right. Therefore, it will be f of 4 over 3. And what is f of 4 over 3? It will now be what? Plus 2 what? 4 over 3 cube. Plus how much now? Plus this now, it will now be x5. What is x5? It will be 4 over 3 plus, that is 4 over 3 plus 1 over 3, which is 5 over 3, which is now 5 over 3. Then this is f of 5 over 3. Then this, it will be 2 f of 2 what? 2 what here? That is 5 over 3 all squared. Now what is x6? X6, it will be 5 over 3 plus 1 over 3, which will be 6 over 3, which will be 2. That is the last one, which is B. And then here, it will now be just f of 2, no longer 2 by. Then the last one here, it will now just be what? 2 exponent 3, because we are replacing it here. Then from there, then this, it will be this. Then you just have to calculate this answer. Is up to this. You just have to use your calculator now, because obviously this will be 1 over 6. Then you multiply it by this. You just have to switch on your calculator, then 2 multiplied by, create brackets 1/3 all exponent 3 plus 2 here, there's 2 here, there's 2 here, 2 here, there's 2 here. Now from there you will get the answer. I haven't even checked the answer. I'm not sure. Did I check it here? I don't know. Or you can just definitely everybody, because this is just pure calculations. Everybody can go and calculate this. This is just pure calculations. You just have to switch on your calculator. Unfortunately, you can't see mine. Mine calculated this. It will be 2 in brackets 1/3 all exponent 3 plus 2 in brackets 2/3 all exponent 3 plus 2 in bracket. You don't even have to write it. Okay, you can write it. 2 in brackets 1 all good plus 2 in brackets 4/3 all exponent 3 plus 2 in brackets 5/3 all exponent. Now don't forget this is all exponent 3, then plus 2 in brackets all exponent 3, then you close brackets, then you say equal to, then you divide it by 6. And I can't remember what the answer here was. I haven't done it. I didn't do it. Oh, no, I've done it. No, I've done it. Looks like here is the answer. I have done it. The answer here, it was more or less 4,11. Yes, it was more 4,11. 4,11. That is the approximation. That is in case this is not integrable. But we can still what? Approximate the area. But now because this one is integrable, you can just simply calculate the area using that formula, using this, and see what are the answer. It will be more or less it is. And we can see that the answer here is going to be this because it's integrable. From where? From 0 to 2. We don't even have to look at what? The second brackets, because the second bracket we are going to replace x by 0. Therefore, the answer here it will be 2 exponent 4, which is how much? Which is 16. 2 exponent 4 is 16. Then it will be 16 divided by 4. 16 divided by 4 is 4. Then the answer here is 4. Then you can see that these two indeed, this is the approximation of this. And in fact, this approximation, it will get better and better and better if you increase what? The number of n. If you increase n maybe to 16, n maybe to 10, this, it will give you a better approximation than this one. Maybe if you increase n here to 16, maybe this one at the end is going to give you 4,001, so on and so forth. Hopefully this makes sense. And what we like about mathematics is what? Is once you grasp one concept, then the others, it becomes very simple. Because with the others, the only difference is just the formula. They work the same. The only difference is what? It is just the formula. I'm talking about this and the Simpson and the mid-ordinate. The only difference is just the formula. This is for the trapezoidal. And now another one, if there is no question, another one, the formula for Simpson. They just differ by the formula. They just differ by the formula or the rule. They just differ by the rule. The rule for Simpson is the following. Ways. The rule for Simpson is the following. Remember, it's still about the approximation. The rule for Simpson is this one. And don't worry, surely you'll be given these formulas, this rule during exams, so that you don't have to waste time memorizing a formula. So the Simpson one is this one. That is 1 over 3 b minus a all over n, where b is still the upper limit and a is the lower limit, and n is the number of those partition, equal partition. But don't forget, they must be equal. Now, the same story. The formula here is f of x0. Don't forget, x0 is a. Don't forget, x0 is a. Now, plus what? Plus, that is where the difference comes in, plus 4x1 plus 2x2. It will depend on how many parts now. Plus, this is 4, this is 2. Unlike trapezoidal, where it was just 2, 2, 2, 2. This one is 4, this one is 2. The next one, it will be 4. It will depend on how many. The next one, it will be 2. It will depend on how many. The next one, they will just alternate between 4 and what. And then the last one, as always, is without the 4 or the 2. It will depend on how many. It will depend on how many. Hopefully, it makes sense. If maybe you still have many to go, it will now be 4 f of x. This is x4, x5. Maybe it will not be the last one. Otherwise, then it will still be 2 f of x6. Then from there, the last one, so on and so forth. And the approach is the same. It will still be n equal to 6. Let us just use the very same thing. Say this one out here. They say approximate this. Approximate this using Simpson's rule now. Then it will now be what? It will now be n is equal to 6. From where to where? Let's say from x equal to what? Say 0 here up to whatever. Up to 2. Meaning this, it will be your A, and this, it will be your B. Now, from there, what is this? It will now be B minus, which will be 2 minus 0 divided by this, which will be 2 minus 0 divided by 6, which will be 1 over 3. Then we are still going to say it will now be 1 over 3. That is this. Multiplied by 1 over 3. Good. And then it will now be f of x0. And what is x0? X0 is 0. Then it will now be here, it will now be 0, because it will be f of 0, which it will be 0, 2. Then it will just be 0, which you can just ignore it. Then it will now be plus 4 f of x1. And from 0, we are not going to keep on eating this. Therefore, it will be 4 f of 1 over 3. Then plus 2 f of what then? That is 2 over 3. Plus 4 f of what? It will now be 2 over 3 plus 1 over 3, which is 1. Then it will be 1 plus what? 2 f of what? Because it will not be 1 plus 1 over 3, which will not be 1 4 over 3 plus. Now, 4 f of what? It will not be 5 over 3. That is 5 over 3 plus, this is the last one, because it's 6. It will be 5 over 3 plus 1 over 3, which is 6 over 3, which is 2. Then it will not be f of 2. Then from there, you calculate this. And that is all. we know f of 1 over 3, this is f of x. Then you just use your calculator and get it. Any question? Any question? Nothing. Now, the last one here, if you look at this, here we were looking at the extreme. If you are looking at this, because we were looking at what? Say something like this. Say we were subdividing this. We were saying this is x0. This is x1. Then this x0 here, this x0 is the left side of this part. X1 is the left side of this part. Then from there, x2 here, x2 is the left side of this. Until the right side here, which is, this is the left side from good, so on and so forth. Until xn, until no, xn, which is b, the right one. But now with the mid ordinate, we are not using the extreme. We're using the midpoint. We're using the midpoint. We are not going to say x0. You say, what is the midpoint of 0 and 1 over 3? You say, this is 0, and this is 1 over 3. This is 0. Then we're going to say, what is the midpoint here? The midpoint here, it will be 0 plus 1 over 3, which will be 1 over 6. Then from there, you can move using 1 over 6. You are no longer going to use 1 over 3, 1 over 3. You are going to use the midpoint, which is 1 over 6. Hopefully it makes sense. The midpoint. You just say, what is the midpoint of this and this? Because this is 1 over 3. And what is the midpoint? Because that is why it's called mid-ordinate. Instead of using the left or the right, you use the midpoint here. Here, you're going to use the midpoint here, which you can just simply say, what is this plus this divided by 2? Because this is the midpoint. Or here, what is this plus this divided by 2? This plus this divided by 2. It will give you the midpoint. That is why it's called the mid-ordinate. And I'm not sure which page is it. Now from there, you can just simply get it. And that is all. I'm just looking at the time here. What is the time? I'm just looking at the time here. That is the time. I'm just looking at the time. Then that concludes this. It's about what, 3 minutes to? Then we can just take, no, 6 minutes to, then we can just squeeze 1 or 2 questions. Even from last week's session, we can just squeeze it. Any question, we can just squeeze any question, whether it's from this session or whether it's from last week, no problem, we can squeeze it in. Any question, any question? Chuma, do you have a question, Kogejo?
No, sir. No, I'm covered.
Will you make it in the exam? Yes.
With
Good.
practice, yes.
You don't even have to ask that question. You don't even have to ask that
Yes.
question. You must. It's a must.
Yes.
If not, we're saying this. If not, then drop me an email. Drop me an WhatsApp. Then I will come back to you. I won't be doing you a favor. No. It's my job. I must do it. I must answer you. Bring your part, I will bring mine. Put them together, then definitely you should be able to pass. Everybody. Do you have a question,
No, definitely.
Elisha?
Yeah, we will.
Yes. Do you have a question, Mandisa?
No, sir.
Will you pass as always?
I hope
Yes.
so.
Good. No, don't say hope so. You must say yes, like that. Any question? Do you have a question? Ashela?
Yeah, so far so good, Minier. If there by any chance will definitely questions will be there with the time. Then as long we have your email, we're gonna just pop in.
Perfect, perfect, perfect. Then if nothing, then we can just call it a day, and any communication, further
Hold,
sessions or what, they will come from Dr. Dlamini.
can you hold on, Minier, before you go?
Yes, yes.
I don't know whether we covered this last week or not, but in case where we are given a parabola or a
Correct.
hyperbola, where we are
Come
given
again.
functions, in case
Come
where we
again.
given two functions of a hyperbola or a
Yes.
parabola, are we supposed to
Yes.
equate the graphs before we
What do you
integrate?
mean? You want to find what? The area enclosed by any two functions.
Yeah, by two functions.
Yeah, to find the intersection of the two functions, then you just have to solve those two functions simultaneously.
Okay.
Simultaneously means what? You can use the substitution method, you can use the elimination method, any method, simultaneous equation.
Okay. In case
Yes.
when we're now going to integrate, are we gonna use the sum of those like the sum of those two functions as the function which we are going to integrate or what?
No, we have said it will depend. That is where we're saying at least have a picture of the graphs of those in that interval, because you must now take what? The function that is forming the roof of that region and subtract what? The function that is forming the floor of that region, and integrate what? The difference, the top minus the bottom. If you are integrating with respect to x, if you are integrating with respect to y, then you take what? The right function and subtract the left function. Remember, if it is horizontal, then you must write both function as what? As x equal to, because you're going to integrate with respect to y. But
Okay.
if you are integrating with respect to x, let's say if you are integrating with respect to x, and remember, some of the region, in some of the region, you may have to subdivide it into more one. Let's say you have got this. Let's say you have got this, and another function is something like this. Let's say the area of this region is two parabolas. This one is opening up, this one is opening down. So obviously you have to find a point of intersection here and here. And then
Okay.
take this one. Let's say this one is y1 and this one is y2. Then A now, it will be the integral of what? Of y1 minus y2 from what is x here up to what is x here, which we have to solve these two simultaneously.
Yeah, understood.
Yes, the question now is, will you be able to integrate this difference? Because this difference, yes, if it is two parabolas, yes, it's simple. But what about if one function is y equal to sine x squared? You see, then maybe it will now be sine x squared here, maybe minus whatever here, 2x plus whatever, because it can still be what? Something like this. It can still be something like this and something like this here. You find it that now here, this one is sine x squared and this one is a parabola. Therefore, you still have to find what? The intersection of this. I mean, if not given, because in some question they can give you the point of intersection of this. But you must know that although here it will be simultaneous equation, but you are not interested in y. You are interested in the values of x.
Okay.
Yes, as we have said, in some instances, you may have to subdivide this into sub-regions, like what? Say you have got something like this. Whatever, say is what? Y equal to sine x. Then they say find the area from x equal to 0, maybe x up to equal to 2 pi. You see. And then you see that this is 0. Here is pi over 2. Here is pi over 2. This is pi. This is 3 pi over 2. And this one is 2 pi. If you cannot subdivide this, the answer is going to be 0. Because this part, because it's above, it's going to give you maybe 3. I'm just giving you an example. And now this one, because it's below, it's going to give you minus 3. Then will be 3 plus minus 3 is 0. Then you must have an idea. But now, if you have got a sketch or whatever, then you can see that, oh, these are symmetrical. Then you can just simply what? Find the area of 1 and multiply it by 2. It will give you the total area. Otherwise, call this one A1 and call this one A2. Therefore, A now it will be the area of A1, which will now be from 0 to pi, where the top function is sine x. Then you integrate with respect to x. Plus, now what about A2? A2, the lower limit is pi and the upper limit is 2 pi. Now, this is now going to be this. Remember here, we have said it is, which is sine x, minus 0, which is just sine x. Now, this one, it will be this, which is 0. This is y equal to 0, minus y equal to this. Then this is going to become minus sine x dx. Then you integrate, get an answer here, which will be 3, and get an answer here, which will also be 3. It will depend. So that is why we're saying understanding the concept is crucial. Once you know, oh, finding the area, I must now take what? A function that forms the roof of that region minus function that is forming the floor of that region. So depending on the region, you will say, okay, if I'm here, the roof is here, and it will be the same in any position. Doesn't matter where. Whether you are here, the roof must be this. Whether you are here, the roof must be this. Whether you are here, the roof must be this. This coming from sine x. But once you get in here, the roof is no longer sine x. The roof is now 0. Therefore, this one now, therefore, it has to change. The roof is no longer sine x. The roof is now what? Y equal to 0. Hopefully that makes sense.
Yes, it does.
Any question? Nothing?
Yeah, by the way, you said starting next week, you are going back to our usual Tuesdays, confirm?
No. Your lecturer is Dr. Tlamini. He's the one who is in charge, is the one who is telling us what to do next. So let us hear from her, but according to what I've learned, I've heard from her, we are done. Then next week, I don't know from when, she says something like she's going to finish what. And thereafter, we will then look at revision. And even with revision, she's the one who is in charge. She's the one who will tell me what to revise, when, so on and so forth. We just have to hear what communication from her. I'm just a tutor here. She's the lecturer.
I'm sorry.
Yes,
Hello?
Martha. Hello, Gogezo.
I'm trying to look for your number here and I can't find it. Can you please give me your number?
My number is there. Unless if you are not in my group.
Which group, sir?
You know, I don't know which group. Because because as I'm saying what is happening is what? Dr. Tlamini gave us groups. So then I wrote everything specifically for my students, my group. And definitely I will add, I will advise, I will inform, because I was not aware that whatever I write, it will be specifically be for this group, and then she cannot. But my number is 082. If you have a pen, I think there is some background there. You can just switch it off. I can see that you are now partying now, Kogetso. 082 398 7601. 082 398 7601. Otherwise, my email is there. But obviously, if you can't see my number, then you can't see my email because they're in the same platform.
Okay, got it, sir. Thank you.
Thank you and bye-bye. Bye-bye. Yes.
Before you go, so like I don't think I'm in your group. Am I allowed to ask question if I have a problem? Can I send you an email or a text, a message asking if I have a problem
You are
with one of
allowed.
my?
You are allowed.
Maybe a question.
I just gave you my number. You are allowed.
Okay.
And you, Mpela, Mandisa, you are allowed. You, Elisha, you are allowed. Any students allowed. Thank you and bye-bye. Going two, going one.
Thank you, sir.
Bye-bye.
Bye, sir.
Thank you.
Good afternoon,
Thank you, sir.
team.
Okay.
Utwang. Ma'am Dlamini said from Tuesday we are going back. We are starting to attend on Tuesday.